Hi, everyone, and welcome to the November 20th Inspektor Gadget community call. Today's call will be recorded, and I plan to upload it to YouTube sometime next week. I am Lexi. I will be flying the ship today, or steering the ship today. And maybe we can just start with a nice round of intros. I could just start. I am Lexi, as I said. I work at Microsoft. I help some of our open source projects with their community engagement. And I am reporting to you live from London. And maybe, Matthias, do you want to go next?
Hi, yeah, sure. I'm Matthias. I'm currently in the train on my way back from a conference in Mannheim. I live in Geneva, Switzerland, and I'm happy to be here.
Fantastic. Welcome. Next, maybe Alban?
Yes, hello. My name is Alban. I work at Microsoft as well in the Inspektor Gadget team, and I'm based in Berlin. And today I will talk about Inspektor Gadget on stack traces.
Fantastic. And Florian?
Hey, I'm Florian. I'm with Elastic, working on profiling, and excited about to see the demo today.
Fantastic. And Amit?
Yeah, hi. I'm here with Ben. We are from the Armo team working on a Cubescape. Also happy to see the demo today.
Fantastic. Welcome. Claudia?
Working. Hi, I'm Claudia. I'm also working for Microsoft within the IG team. Fresh back in the team after a long leave, parental leave, and I'm looking forward also to see Alban's demo here to get me a refresh of the project.
Did I say that right? Sorry. Oh. Okay, maybe not. Maybe Patrick? Sorry, I know you just joined, but would you like to do a little quick intro? It's okay if not.
Yeah, sure. Like, give me a second. I will try to get my video working.
Cool.
Yes.
Got the floor really quickly when you joined.
Yeah. So hi, I'm Patrick. I'm currently working at Migo. I kind of joined because I did some parts of I helped Album with parts of the stack traces, and I'm just here to hear how it played out. Curious about the update.
Fantastic. Yeah. Really happy to have all of you, and nice to meet everyone. So yeah, I think we should just give Alban the floor, since that's why we're all here. So Alban, you want to take over the steering?
Thanks, Lexi. So let me share my screen. Does it work? Can you see the slides?
Yes.
Okay. Yes, so I will talk about stack traces in Inspektor Gadget, how it works today, what we want to do, and how we can integrate with the OpenTelemetry eBPF profiler as well. So this will be a status update about how it is in the project today. Okay, so before talking about stack traces, I wanted to make a short introduction about Inspektor Gadget for those of you who don't know. What we want to do is kind of like being the Docker for eBPF programs. So with Docker, you can have an OCI image. You can use commands like docker build, pull, push, run, and so on. And you have an equivalent command to build eBPF programs from the source code into an OCI image that include the eBPF bytecode, and distribute it on OCI registries with push-pull, run them either locally or on Kubernetes with kubectl gadget, kubectl plugin, and so on. So at the moment we have about 41 different gadgets that are published on the Artifact Hub. Some of them are kind of the official gadgets because they are part of the same repository as Inspektor Gadget. But it's like Docker, you don't have to be part of the project to write your own gadgets and publish them. So some of them are third-party gadgets as well. And there are gadgets about tracing, about observability, or about security, or about networking. There are whatever you want to do with eBPF, we would like to enable with Inspektor Gadget to share your eBPF programs in that way. So Inspektor Gadget is a command line tool, so you can get a stream of events on standard output, JSON or YAML, and so on. But it's other exporters and other UI. Here are two of them. One is Inspektor Gadget Desktop. That's a UI showing Inspektor Gadget, so you can start gadgets, stop gadgets, and so on, either locally or connecting to a remote host. On the right, it's Headlamp, and Headlamp is a Kubernetes UI, and it has a plugin system. One of the plugins is for Inspektor Gadget, so you can use the Inspektor Gadget plugin in Headlamp to start gadgets in your Kubernetes cluster. And then there are other exporters. The one on the left is something that works today in the release. So you can, some of the gadgets can export metrics, and you can export them as Prometheus metrics, and then you can view them in the usual way. For example, in this case, in Grafana. This is an example of one of the third-party gadgets showing the amount of system calls. On the right is something that is not merged. That's something that Mauricio is working on. And this is getting stack traces by a gadget in Inspektor Gadget, exporting it using the OpenTelemetry profile gRPC protocol. And this is a screenshot of Grafana and Pyroscope to display the stack traces generated by Inspektor Gadget. So this is a work in progress that's not merged, but you can look at the pull requests here. And that's something I wanted to demo right now. So let me try to share my screen with the demo. Second. So hopefully you see my terminal. On the first terminal windows, I have a Docker Compose setup where I will start Pyroscope on Grafana. So it's starting. On the second terminal, I have Inspektor Gadget configuration. This is telling Inspektor Gadget I want to use a specific exporter that will connect to, that will send the traces to Pyroscope on Grafana. And here I have, this is the IG binary from Mauricio's branch. I will use a gadget called Profile CPU. What it does is running perf event to get the stacks from the system. So this is the OCI image. And I will export this on this exporter. Okay, so let's try to do this. So it will start the gadget. And meanwhile, I have a third window where I have just a Docker container, and I will generate some CPU intensive workload. So now it will generate a stack by Inspektor Gadget and send them to Pyroscope and Grafana. So let me share other screen. Sorry. Okay, so that's Grafana running on my laptop. And I have here the profiles. It should show the data from Pyroscope. And if I go to the flame graph here, I see the flame graph here. And So this is a proof of concept. The work is not finished. So far, we only get the kernel stack. But in Maurice's pull request, the goal is to complete the work to get the full stack. What we see here is the function in the kernel that are generated by this cat workload that generate random numbers. So that's it for this demo. Let me go back to the slides. Okay, so now I want to talk about the different use case. Why do we want stack traces in Inspektor Gadget? I listed here 3 different use cases. So the first one on the left is for ad hoc trace events. So we have a lot of gadgets. Some of those gadgets will benefit from getting stack traces. For example, trace capabilities. That tells you whenever a workload on the system want to exercise a Linux capability, for example, capsysadmin. When that's the case, it's useful to know why this happened, and getting the kernel stack on the user stack is useful for that. So that's an example of use case where the events might not be happening so often, and it's an example where missing one trace will be bad because the goal is to get all the events on all the stacks. Another use case in the middle is ad hoc profiling. So something you don't run continuously, but just when you want to investigate something, you start some specific gadget for some specific use case. Maybe you have written the eBPF code yourself for debugging a specific part of your system, and then you run it for a limited time to investigate what's happening. And the third use case is continuous profiling. That's more what OpenTelemetry is doing. And so we can reuse some of the gadgets, for example, profile CPU that I showed in the demo. And the goal here is to run it continuously and not just for some time. And in this use case, what is important is the performance. We don't want to have many percentage of CPU lost in this task because this is supposed to run continuously on a production system. In this use case, missing one trace is not too bad because what matters in the end is statistically get a representative view of what the CPU is doing. Okay, so here I go back to the trace capability gadget, and I put an example of workload in Go running some system call, chroot in this case, and because we need some capabilities for this system call, the trace capability gadget should show what's happening. So on the bottom, you see an event for every system call that requires this capability, and the stacks generated here by Inspektor Gadget. In this case, we're using OpenTelemetry, but I will come back to that more later. This example is a program in Go, so it's kind of easy because the program in Go has a symbol table and is able to get the stack this way. The next example is with Python. And so it's an interpreted language, so it doesn't have a symbol table in the ELF file, but still it shows here that OpenTelemetry was able to get the stack. So this is an example of using a gadget in Inspektor Gadget, and this eBPF code from the gadget will call the eBPF code from OpenTelemetry to be able to resolve the stack, even in complicated cases like Python here. Okay. So now I want to go back to the history of Inspektor Gadget. So Inspektor Gadget started in 2019, but the first support for some kind of stacks come from 2 years ago. And at the beginning, it was only kernel stacks, only in built-in gadget, which is something we don't have anymore. Nowadays, we have image-based gadget in OCR image. And then later on, a couple of years ago, we get the support for image-based gadget. In some gadgets like TCP drop or capabilities, those are gadgets with stack trace support. And later on, we added support for user stack traces. I say limited support because At this point, it was only supporting compile language, not things like Python or JavaScript, and only on some of the gadgets. And later on, we added support. We added the implementation in more gadgets, and we refactored the code to have a new option in Inspektor Gadget called /stabilizer. And this allows to specify different kind of stabilizer. So you can use the built-in one in Inspektor Gadget. The goal is to add the OpenTelemetry one because it is more, it has more feature and it works better in general. Otherwise, we had some fix and some support for client-side symbolization, which is useful when the binary might not have the symbols, but you can have access to them externally, so you can build systems where we have we can resolve the symbol later on. And in the future, what I would like to have is this new symbolizer based on the OpenTelemetry BPF profiler. So we have a proof of concept pull request for that. To have the exporter, what I show you, exporting to Periscope on Grafana using the OpenTelemetry protocol, and having support for displaying flame graph. Okay, in Periscope Grafana, that's already done. In Inspektor Gadget Desktop, that's not done yet. That's what I would like to have. Now, if you would like, I will explain how does it work technically. What are the steps that all software that want to do resolve stacks have to do. And in general, that's split in kind of two tasks. One is stack unwinding, that is getting the address of the function from the stack. And then symbolization, converting the address to the name of the function. It's not always very clear, the separation, but it's more or less how it works. And to do that, here are some concepts that are useful to understand. The concept of a virtual memory. Every process has its own independent virtual address space, composed of different VMA for virtual memory area. And yeah, some other concepts I will explain a bit more later on. For example, programs can be loaded in memory at a different address that is not deterministic. So the kernel can choose randomly where to load the program. So that will bring some challenge into how to resolve stacks later on. Okay, I will go to the next slide. This is kind of a summary how a program is loaded into the memory, into its virtual memory. And that's something you can see via procfs. So if you look in /proc/bits/maps, here you can see the different memory region loaded in the virtual memory of that process. And so I explained some concept here. For example, some memory mapping are mapping a specific file, like the executable cat in this example. And you have the concept of runtime-based address. The first address, that's where the kernel decided to load this program, which is chosen randomly, typically, so to make it more secure, less predictable by attackers. And there are different kind of VMA for the stack, for dynamic libraries, and so on. How a program is loaded into memory, that's described in the executable file. There is in the ELF format, there are program headers that specify how to load a program into memory, and that will be described how this program is loaded here. And with both of this, we can use that to resolve a stack. How it works, we get the list of addresses for all the functions in the stack. The first one is from the register program counter. And in this example, that's pointing to somewhere in the cat, the memory of the cat program. And then for the next addresses in the stack, we have to read the stack. So hopefully we have a stack pointer and base pointer where we can follow through the different addresses. Once we have the different addresses, we have to resolve them to get the symbols. And in the easy case, we have a simple table where we can look up that. And then we have to apply an offset because the program has been loaded at random memory. So we have to adapt for this bias. Okay, on this this maps file, ideally we should not look it up for every time we want to resolve a stack. Yes?
May I have a question?
Sure.
So if there is no base pointer, like the code was compiled without using BP, is there a way still to recover the call stack?
Yes, there is a way. I will present later different methods to do it. Some of them don't support it. So in Inspektor Gadget today we don't support it, but using the OpenTelemetry method, it's supported because OpenTelemetry does it in a better way.
Cool.
So depending on the level of support you want, you might want to use the OpenTelemetry backend instead of the the one in Inspektor Gadget.
Thank you.
Okay, because of time, I will skip that slide. But this is to explain how the data structure in the kernel work. And I will go to this. I will explain 4 different methods to get the stack, and some have pro and cons for each of one. The method number 1 is the easiest, I will say. This is supported in Inspektor Gadget. And that's to use the BPF helper function, BPF get stack or get stack ID. They both do the similar thing. They get, it will ask the kernel to unwind the stack and get the list of addresses for all the functions. And later on, to make sense of that, we need to look at the maps file to know what are the different dynamic libraries and executable used by those addresses. And so you need to have access to /proc PID maps to make sense of it. The method number 2 is pretty similar, but in this case, we will not get the list of addresses relative to the virtual memory of the process, but we will get the build ID, which is different for every executable, and an offset relative to that. So since that's not relative to the virtual memory of the process, it means you can do the symbolization later on a different host. It can be done remotely, and we don't need to have access to the process. It doesn't need to still be running. So those 2 methods are today supported by Inspektor Gadget, but they are quite easy to implement, but they have drawbacks. First, it doesn't work if you have a frame pointer. So that could be annoying if your workload are compiled in that way. In practice, that often works because most of the new Linux distribution don't use omit frame pointer, so it works fine. But still, it doesn't work with interpreted language like JavaScript, Python, and so on. So we need more methods. The method number 3 that will help for programs compiled with omit frame pointer. What we do, instead of asking the kernel in the BPF helper function to unwind the stack, we will just copy the full stack, or maybe not the full stack, but at least 200 bytes or 4 kilobytes, send that to user space, and then user space will interpret that using lib unwind, for example. So it will, even though it was compiled with omit frame pointer, maybe you have the dwarf information, and that will allow you to resolve the stack. We don't use that method in Inspektor Gadget, but that's something that is used by BCC in some pull requests, and by perf if you use those flags. And the last method, it's what is used by OpenTelemetry. So in this case, we don't do post-processing, but pre-processing. So when OpenTelemetry BPF profiler knows that a process has to be, we have to be able to get the stack from it. It will do a pre-processing with the binary and understand how it is and prepare eBPF maps so that the eBPF program will be able to unwind the stack correctly. So that's a lot more powerful. And with that, you can work with omit frame pointer. And it has different eBPF program to unwind different kind of stacks, for example, for Perl, for PHP, Python, and so on. There is still some post-processing for the interpreted language, but the bigger part of the job is this pre-processing to prepare the eBPF maps. So this method by OpenTelemetry, it works with the omit frame pointer and it works with interpreted language, so that's really good. It has still some drawback. Some of them are problematic for Inspektor Gadget because generally it doesn't work for the very first stack request you get from a process. Unless the pre-processing work has been done by OpenTelemetry, the first stack will not work. So in general, for the use case for continuous profiling, that's not a big problem because we don't necessarily want to get all the stacks, but we want to have a statistical analysis, what is the most CPU intensive task. But for some other gadgets in Inspektor Gadget, for example, the trace capabilities or some other thing where we want to detect security problems, that could be problematic because programs like chroot or mount, they are very short-lived and they might generate only one task. If we miss them, then that we miss the point of the gadget. So that's the pro and cons of each method. And then later on, for symbolization, converting the address into the symbol, there are different methods. So what is implemented in Inspektor Gadget is passing the elf section with the symbols or using external symbols. There are other methods are listed here, but I will not talk more about that. This maybe I will come back to that later if we have time. So in Inspektor Gadget, it works this way. The gadget doesn't have to specify which method to use, like gadget author write the BPF code one time, and then when the gadget user want to run it, they can select which symbolizer to use. So it could be reading the symbol table from the ELF file, or reading an external database of symbol table, or with a pull request that is not merged yet, using the OpenTelemetry eBPF profiler. So the goal is to have gadget authors writing their gadget one time, compile it one time, but then dynamically adapt to whatever the user prefers to use. This slide is just to explain the difference between on-demand symbolization or deferred. On-demand is when we want to immediately resolve the symbols. And that's what we prefer to do, especially for ad hoc tracing. We don't want to just store in the database something to resolve later, but we want to get the symbol immediately. It's either possible to do deferred symbolization, and sometimes for continuous profiling, it could be preferred because it's less CPU intensive. And then you get a database of stacks, and you might want to resolve them later when there is a need for that. Okay, so now we'll talk a bit more about OpenTelemetry eBPF profiler and what we want to do with it in Inspektor Gadget. So as you have seen, there are two things I would like to have from that. The first thing is using OpenTelemetry eBPF profiler as a Go library to get stack traces in a better way that we have today in Inspektor Gadget. So as I explained, it will be an option, not necessarily enabled in other case, because for some gadget it will not work well, but for other gadget it will be better. And the second thing I would like is to reuse the OpenTelemetry profile gRPC protocol that is being developed to export stacks. So exporting stacks to an external process like Grafana on Pyroscope. We don't want to redesign the protocol, but it's better to reuse something that has been designed for this. So those are the two things. And we'll talk a bit more how does it work on the eBPF level. So when you have Inspektor Gadget, that's a process in user space that starts a gadget. So the gadget will bring its own BPF program, in this example, a kprob. And that kprob might call a function in BPF that is provided by the Inspektor Gadget library. And I'm not sure how to name it, but in this example, I name it gadget fetch OpenTelemetry from kprob. What it will do, it will in the end call eBPF code from OpenTelemetry, but before that, it will store in the BPF map a context for the current CPU, so as a way to communicate between the two programs. And then it will do a tail call to a BPF program that will call the BPF program from OpenTelemetry. In this case, the program called vprog generic. That's the entry point from OpenTelemetry for all kprobs and uprobs. And then, thanks to a patch from Patrick in this call, this can fetch an identifier of the context. And then this eBPF program from OpenTelemetry will do a series of tail calls to resolve all the stacks frame from the program. And at the end, it will send back to user space in a ring buffer managed by the OpenTelemetry library. It will send the stacks that will be interpreted by Inspektor Gadget. And then the tail call will return. It will continue the execution of the eBPF program provided by the gadget. And then it will send an event as well for the managed by the gadget. And Inspektor Gadget will be able to resolve those two, the two events from the two ring buffer, and see that, okay, that's an event, for example, from the trace capabilities gadget with a stack with the stack ID, and that is provided by OpenTelemetry. Okay, that's how it works in the proof of concept. I'm not sure if I will have time to talk about that. That's just internal implementation details in OpenTelemetry. How do we prepare the eBPF maps so that the eBPF program will be able to unwind the stack? So that's the pre-processing I talked about before. It will use a longest prefix match map to be able to map the address to the programs. Something I was wondering about is it possible to filter by stack? For example, a gadget might emit some events with some stacks, but maybe not all of them are useful. And in some use case, we might want to filter only for some specific stacks. If we want to do that in user space, that's already possible because we have a generic filter operator in Inspektor Gadget. So we can filter by a string, by regex, and so on. So it's already possible to, if you want to specify a regex for a stack that you want or don't want, then it's already possible to do that. But I'm thinking maybe in some use case, it might be useful to do that in eBPF. For example, if you have a kprob or trace point that is fired very often, then you might not want to send an event for each of them, but get the stack only if the stack match a specific pattern. I'm not quite sure how to do that because in eBPF we don't have the symbols exactly, we just have the addresses, and the symbolization is done later in user space. So we will have to pre-populate some maps to specify which stack we want. That's a bit tricky. Okay, how does it work for Inspektor Gadget authors? When you write a gadget, you will not use a different API in your eBPF code than what is provided today. The goal is to write the code one time, and you don't specify if you want to use the BPF get stack ID or the OpenTelemetry method. Inspektor Gadget will automatically redirect the calls to either the OpenTelemetry if the user of the gadget wants that, or to stay on the Inspektor Gadget method. And we can do that either with eBPF extensions or tail calls. That's something we can configure at runtime without recompiling the gadget. Now, I wanted to maybe not make a demo, but going through this guide. So I will stop my screen and share the guide. Just 1 minute. Okay, can you see my screen?
Yes.
Cool.
Yeah.
Okay, so let me go back to the top. That's a documentation for Inspektor Gadget, but that's not something merged in the main branch. That's just from the branch on my pull request on for the OpenTelemetry integration proof of concept. So what I have at the top is a simple C program. So you can see the stack will contain different functions. And then I compile it many different times with different compilation options. Sometimes it's statically compiled, sometimes it's dynamically compiled, or stripped or not stripped on, with different options. And then using the Inspektor Gadget, I use the trace capability gadget. This gadget is, you can see the C code, the BPF code for this. What it does is just a kprob on this kernel function that will be exercised whenever a capability is exercised. And then it will get the stack and get the stack somewhere here. And then send an event to user space. So when we run the basic program, it works fine. We can get the stack. That's done using the simple table in the elf file. When we use the strip version, it doesn't work as expected because we remove the name of the symbols. But I use this as an example because quite often in Linux distributions, binaries are provided without symbols, but still there is a public database of symbols that you can fetch from public database. And then it will be queried using the build ID. So if you have not fetched that database at first, it still doesn't work when you run Inspektor Gadget, but it will provide you with which command to run to be able to fetch it. So if you use, in this example, debug info defined on this build ID, that it will download the symbols. And then next time you run the program, you will get all the symbols So Inspektor Gadget doesn't by itself download anything, but if the database, these symbols have been downloaded on your system, then it can make use of them. Next, I show it works with different kind of executables. With position independent executable, it works as well. And it works with kernel stack as well. In this example, I show the kernel stack. So far, that's things that already exist in Inspektor Gadget. What is new and is not merged in Inspektor Gadget is using the OpenTelemetry library. And for that demo, we can demo it with Python because OpenTelemetry BPF profiler supports interpreted languages. And then here the difference is I will run Inspektor Gadget, but I will use this specific symbolizer. So that's the same gadget as before. I didn't recompile it, but what changed is the symbolizer we use is the one provided by OpenTelemetry. And because that's a proof of concept and is not well finished yet, I get the result just in the debug message, but you can still see the point that OpenTelemetry was able to get the kernel stack and the user stack, provided all the line numbers and function names from the Python script. Okay, so in this example, it's using a Go binary, but it was stripped. And I noticed that even in this case, OpenTelemetry was able to get the symbols back. That's quite cool. But there is still a limitation that OpenTelemetry doesn't manage to get the symbols for the very first symbol request, as I explained, because he didn't have time to pre-populate the eBPF maps. But for the second one, it had time to get the to pre-populate the maps, so it worked in this second attempt.
Alban, can I ask, do you have any idea if this can be solved somehow, even with like a hack, whenever we see like a process start, somehow, ping the hotel profiler to know this process or something?
Yeah, I'm not sure. I think it might have an API to say, please populate this process. I'm not sure if it exists, but I think even if it exists, that will not completely resolve the problem, because there might still be a race condition. If you consider short-lived programs like Mount or chroot, by the time they start on the system call that you want to trace, OpenTelemetry might not have the time to parse the file.
Yeah.
So if you have long-running process, this could be solved by either using or adding this API, but that will not work in all cases.
Yeah, thank you.
Okay, I see on the chat that Florian replied as well.
Yeah, maybe it's like worth thinking about creating an API that will solve the cases for long-running processes. For short-living is obviously more challenging.
Yes. I think that depends on use case too. If you want to use it for security purposes, then maybe that's not good enough. If you might still miss something, but if you can accept that sometimes it might not work, that could be okay.
Yeah. Thank you.
Okay, so that was the second demo. I wanted to say a couple of words about security. In general, I would like to Inspektor Gadget to work even if we have some malicious workloads. So yeah, this is just a general slide. This slide is nothing to do with OpenTelemetry or Inspektor Gadget. That was just an example of security issue called the confused deputy problem. And this was something that happened in a very old version of Kubernetes, where before the way kubectl exec work, it make a request to the API server, and then it talked to the kubelet using some HTTP endpoint. And normally, if everything goes correctly, it talks to containerd to get the request, to do the request. But in the case where the kubelet run on it has been patched maliciously, then it could reply, HTTP reply move permanently to go to some other point, and it could trick the API server to connect to something else. This trick doesn't exist anymore, but that was the case in a very old version of Kubernetes. And that's quite bad because it means that the user running kubectl exec could use this mechanism to inspect some endpoints that he should not be able to inspect, and looking if the error is NX domain or connection refused or invalidated certificate, you can infer some things about the network that you should not be able to access. And another category of attack is side channel attacks. Why I talk about that? Because we run Inspektor Gadget on a host. That's a privileged process, and it will inspect some workloads that are unprivileged, and some of them might be legitimate and some not. And it's to show that we have to be quite careful about inspecting potentially malicious workloads. When we get information from them, we can be fed bad information. So that's not something we want to solve completely. For example, if we cannot prevent a malicious workload from reporting bad data, that's always something that a malicious workload can do. But what I would like to have is to make sure that Inspektor Gadget doesn't crash. For example, if there is a bug in the symbol table parsing and the malicious workload has a bad symbol table, I don't want to cause anything bad in Inspektor Gadget, or I don't want to cause a denial of service, or I don't want Inspektor Gadget to report bad information about a legitimate process if another process try to do cache poisoning. So that's just something I would like to keep in mind whenever we design solution for user stack traces. Okay, that's all what I wanted to talk today. So what's next? I would like to complete this work about using OpenTelemetry as one of the methods for getting stacks, and complete Mauricio's work on exporting stacks using the OpenTelemetry protocol. And then there are some other tasks that would be nice to have. But maybe we can use the rest of the time for questions or discussions.
I have a question. So if the resolving of the traces that's coming from the eBPF is in user mode, will you provide an operator of the OpenTelemetry to resolve that?
Yes. So maybe I can go to the code. So we have an operator called user stack already. And this operator has some parameters to decide which method to use. So that's something that already exists, but is not the OpenTelemetry one is not merged yet. Maybe I can share my screen. Okay. So in the package operators directory, one of the operator is called user stack. And it has some parameters where you can specify if you want to use OpenTelemetry or not. So if you use Inspektor Gadget as a library, but you don't use the IG binary itself, you can still use this useTag operator.
Yeah.
And configure it this way.
And I wanted to ask, maybe even Florian can answer. I know there was a planning in Hotel Profiler to support also non-interpreted languages symbol resolve. I think there was like a big Rust project integrated into the Hotel project. Is that already supported? Like resolving the CNCPP against symbol servers? So not simple servers, but the local information you have.
I'm not sure I get the question correctly. So I can tell that hotel profiling does not have a way for post symbolization, meaning that the symbolization for especially for native code like Rust, Go, and C does happen in a later step, for example, on the backend. There was back and forth about a protocol for doing so, but this work is still in progress. For Go, there's a special use case. Hotel eBPF profiler switched to a case where we say, or where we treat Go as interpreted language, and so get symbols for Go from PCLN tab. So the very same place where you get your panic logs, or that's where you get symbols from your panic logs. That's why Hotel eBPF profiler also works with script symbols, because for the panics, Go PCLN tab is still there. And for the rest of the interpreted languages like Python, .NET, Ruby, Erlang is was just added. For all these languages, symbolization works out of the box, so there's no post-processing, it just works. Hope this answers your question.
Yeah, thank you.
Does anyone have any other questions for Alban? If not, then we can just wrap up. Thank you so much, Alban, for the great presentation and demo. As I mentioned, I will be getting the video for this up on YouTube early next week. I'm out tomorrow, so probably Monday or Tuesday, and I'll post the link in the Kubernetes Slack channel, and I'll make sure to get the slides from Alban and post them as well. So thank you again. And the next community call will be December 11th. And in the meantime, you can chat with the team on the Kubernetes channel or GitHub. But we'll wrap it up there. Thank you so much again, Alban.
Thank you, everybody.
Thank you.
Thank you very much.
Thank you. Bye-bye.
Bye.